So thank you for taking the meeting invite that I sent through, or accepting it. I'm very keen to just talk through some of the ideas that you've got put forward in the proof of concept, mostly because I'm looking to understand more about the problems that we're trying to overcome and what we want to do about those things, because what I think you're proposing was probably going to take some time to implement, and I want to make sure before we start that this is the right way to go. So that's sort of that just to frame the conversation. But I know that to start off with, you wanted to go through the questions that are already on the merge request. So do you think we should start there and then get to any other questions?
Let me share my screen here.
Okay.
Can you see my screen?
Yes, I see the diagram.
Okay, great. I think that we can start on the behavioral questions that I posted a few minutes. Just about the abstraction. Basically, what I'm proposing here is to standardize how we produce events, how we consume the events, and trying to get away of all of the schedulers that we have today, making our event system more readable so you can trust in it, make sure that it can handle all the events and it can process them. You don't need to have those schedulers doing expensive queries in the database to find out what we need to sync or we need to re-verify, this kind of stuff.
So when you say that it's an expensive query on the database, is that the queries where you're connecting the two databases together to find the things that need to be done?
Yes.
Okay.
So I think that I tried to explain the diagram. I think that most of the questions here, because it's not so clear what each parts are responsible for what they're trying to do. So here, basically on the primary node, we will not have a lot of changes. Basically, we have just a standard way to produce the events with common interface for all types of events that we need. The changes starts on the secondary, here.
Can I ask a question?
Yeah, sure.
So we are keeping more or less the Geo, is it a Geo event table? And the way that we store data there, it will be more or less the same. Is that the proposal?
Yeah, I don't have a formal proposal for how we should store the data in the database. I think that is open for discussion. I'm not sure if the best way is to keep the way they are doing today with a lot of tables, or we should have only one table with a JSON database, a column, sorry, that store the payload. But this is open for discussion. So here, this will be the change here on the how do we start the events. I think that you can start in using what we have today. It's not to not be so disruptive of what we have. But here, the director is like our geolog cursor, but he's responsible only to stream the events from the database. For example, they will know that a new event arrived on the secondary node. You recreate this event as an object when you put it on the event queue. The event queue, like the Toon and Mike asked, it's also open for questions. We can have only one queue, like we have today, in starting processing all the events on this queue. And you can also have some queue per event type, or further in the future, you can start and make some improvements and have a queue per project. I don't know, for the most active projects, something that you can think about this in the future. So this queue here will be like a queue it's not in memory because I would like to persist this state in the regis in case of some failure of the geosecondary node. If you have some failure here, you have all the data on the regis and you can hydratate these events when the geosecondary node is spinning up. And here, let me see how I can explain this. It's not the sidekick workers like you mentioned, Gabriel. It's something that we have this queue in memory, and we have some workers like our real geolog cursor that are picking these events to process. So you can have some priorities here if you need, and you can have a lot of improvements here for what we need. Also, something that I forgot to mention here on the event queue, if you have all these events in memory, we can compress our backlog of events that we need to process as well. For example, we have 10 events to sync the GitLab project. We can compress this to have only one event, and the final result will be the same, because I know that you can do this for some kind of events, but you can do it for another kind of events. But I think that the most common events that we have in our database is the repository sync update event. That's just to sync a repository.
So can I ask a question there about the reading the queue and reading the events out of the database? So at the with this, in this diagram, there's a piece of code that reads the information out of the database and puts it into the event queue. But that piece, you're proposing to actually use the different piece that's built into Postgres in terms of streaming out the information that's there, rather than performing the read queries to get the data. Am I right in understanding that that's the main difference between how the read is happening out of the database in this method?
Yes, here I'm suggesting that we use the streaming that I implemented for the backfilling worker.
Okay, because it sounds, this also might just be something that I'm not understanding, but it sounds like at the moment in the event tables in the database, that is a queue of work, but the queue is in the database, it's not in memory. And we read the queue out of the database and process it at the moment. And it looks like the main change here is to read from the database using the streaming mechanism into a in-memory queue. I say in-memory because we'll still persist it to a cache, but an out-of-database queue that then gets processed.
Yes, it's the biggest difference, yes.
Because when I saw this, the first thing that popped into my mind was the queue is moving from the database into memory. Like we're using the Postgres replication to transport the queue information to the secondary node. But when I start to read about eventing and messaging in this context, it feels like we could actually use eventing from the primary node directly to the secondary and bypass the replication step. I mean, yes, we would still need to replicate the database across, but using eventing from the point of the primary into an event queue. So almost when the events are created on a primary, they get put onto a system like RabbitMQ, where you can then push the message to multiple secondaries, and the secondaries read the message and process it on each secondary.
Yes, this way you just need to change how do we read these events here. We don't need to change anything on the geosecondary. We just need to change how we're handling the events gestion here.
In these diagrams, yeah.
Yeah.
I also have a question here. So by looking at what we have today is that we store all the events in one or more tables. We use the replication to transfer that information from the primary to the secondary. Then we use the cursor. We read them, and right after we read them, we create sidekick jobs. So this is the current architecture. for the next one, instead of reading events on the secondary and creating the psychic jobs, you're proposing that we store it somewhere. It can be in memory or it can be Redis, and then you have a separate process for getting from this data store and executing them. But it's hard for me to not seeing this as we implementing a background job system in parallel. Like if we have a queue of things and we have a worker that consumes that and then it executes it, it's a background processing system in a way. And but the only difference is that we may have like some custom code with the queue somewhere doing some magic, but it's still for me a background processing.
Yeah, if you think this way, you looks like that it's like a background process, of course, because we need to process the events, but we need to keep track of the events. Nowadays, we keep track in the database, and we also have the gap. We also track the event gapping, and here I'm just trying to break this into more smaller classes with a single responsibility. For example, this guy is responsible only to write the events from the database, put it on the queue. And we have another one that it's basically the log cursor here that is just read the events here and schedule the jobs as we're doing today. So, and this is the basic change in the architecture. It's not so high, but just to make every piece with only one single responsibility. For example, today our geolog cursor needs to know how to read a database, the events from database, needs to know how to track the event gapping, needs to know how to schedule a job, they need to know a lot of things. So now I'm trying to break this into smaller pieces, and I'm trying to make sure that our event queue is readable, because, for example, I forgot to mention, with this, I think that someone else also added a comment about this on this issue. We don't need to have the backfilling worker running every time. We can trigger a backfilling from the secondary, so the primary can start triggering some events, or even the secondary can run this backfilling worker once and fill the event queue. And in case of failures, another thing is, in case of failures, even for the repository sync or repository verification or download of an artifact, the idea is not to have the scheduler running a query between the secondary database and the tracking database. We are putting another event inside the queue. So this is the big difference today, because our director here is responsible to read on the database. But in case you have a failure, we don't need to track this in the database, the event itself. The job can just put another event to the queue, and as soon as that another job is available, he will try to sync the repository again. We get rid of the database to find the failures. We still keep the tracking. We already know that a sync failure here, we need to keep the status, but you don't need to run those queries to find what you need to verify or to resync.
It sounds to me that what we are trying to do is like improve the reliability of how we handle the jobs. I'm having a hard time not seeing like this whole thing as a reliable background job system that could be generalized as this. these concerns like about not losing the jobs or making one job unique, for example, when you have a repository update, you want that operation to be unique among the pending jobs. So you're only executing it once for that particular project, not like multiple times. Perhaps all this whole thing could be simplified into maybe investigating RabbitMQ or stuff like that, and using.
Yeah, but the problem is that we need to basically it's not a readable job processing system. It's a readable event processing system. It's almost the same, but we the event streaming. So we need to make sure that we are processing the events in a readable fashion way. So then we are processing the events. We make sure that we not lose any events. Then we start triggering the jobs. It's not responsible for the event system to make sure that the job is running. We just make sure that the events that we don't miss any events here.
No, I get that. I mean that RabbitMQ and a few others that you mentioned earlier on the issue, they can be used as a message event bus or event broker, etc. And some of them have like this reliability characteristics that we need. And the whole idea is that if we find something that works for us and has like this kind of feature that we need, we can remove remove Postgres entirely from the diagram. So we keep we keep the event generation on the primary. It feeds like multiple channels, well, like for one for each, multiple topics, one for each geo secondary. That gets replicated or that gets transmitted to the other side. Each one consumes that, and then so that this whole thing is like from the secondary directory event queue and the workers, and then you have something that just triggers the consumers here.
Well, that's what I was trying to that's what I was trying to get at earlier, was that it sounds like in the diagram that's shown here, it feels like the queue is just moving out of the database into a more standard queuing mechanism that you could populate directly out of the primary. Like at the moment, the Postgres replication is really responsible for moving the queue to a secondary, but the events could be published straight out of the primary onto processes that exist on the secondary nodes that then populate the database or backfill in, or that process all of the events on each secondary.
Yeah, basically what I'm trying to do here is mimic some of these features that Kafka or the RabbitMQ already have, but we know that it's really hard for us to add a new dependence to the GitLab stack. So the idea is to prepare our code base.
But I think that I'm sorry to interrupt, but even though it might be difficult to add something like to add new dependencies to the code to the stack, if it's going to be something that provides an absolutely massive advantage, there is always a case to be made to put that in. For me, if we're going to go down the route of creating an eventing system, we may as well use a system that's already in place and trusted and tested and all of those things. And if that means we have to put a case forward for, please, can we put this in the stack? I think it's worth the effort to do that.
Sure, I agree. I think that the code to write this event is very easy. I can try to do a proof of concept of this to make sure that it's working. I think that would take me 3 or 4 days to write this. But I was thinking about this. For example, if decide to go with RabbitMQ, is that we still need the Postgres replication because we need the information on the secondary node. And if you decide to go to these other tools, we need to think about, for example, when we receive an event on RabbitMQ or on Kafka. For example, we receive the event to synchronize the GitLab repository, but we have some database application lag. We don't have the information in database yet. How you can handle this? I think that this is something that you need to do some investigation.
Can I propose something here? I think you're on the right direction with what you're thinking here, but maybe instead of thinking it as like individual components that will be implemented as a code, try to identify all these characteristics that this magic queue that we want to use should have, like all the, for example, it should be able to handle the case where you have like 10 updates to a repository and it needs to deduplicate to just one, for example. All these things, I think it will be better to like, it will give us more room to either implement it or move to an existing solution. Because if we understand all the requirements that we need to fulfill, it's easier to think about it. I was thinking that, let's say that we decide to implement it, or we decide to use RabbitMQ or something like that. We should probably also consider that some users will install this queue solution, and some will want to use something like Amazon SES or the Google equivalent, etc. So if we have like all the requirements of what this communication channel should do, we can like come up with different solutions or maybe a better solution at the end.
Yep, I agree.
I think the other thing that is coming to mind is it feels like there's actually two pieces to what you've written here. There's one piece which is the eventing queue, and there's the second piece which is changing how we read the events from the database. And I almost think that those are two separate pieces. I think that we could implement an event queue with the system that we have right now without changing how we read the events out of the database. Or we could change the events, how we read the events out of the database without making the change of the event queue. And one of the things that comes to mind is, I don't know if we should do both of these things at the same time. That it might be worth first starting with looking at different ways to stream directly out of the database, because the first concern that you cited was expensive queries, and putting an event queue in place doesn't change expensive queries, but looking at a different way to stream out of the database does. And maybe it's worth actually splitting this into two separate proposals, saying we can change how we read out of the database, and then we can change how we process events. And that might also make it easier to make either of those changes and easier to evaluate the two things separately, because I do think that they're separate things, but I'm open to that being wrong.
Yeah, that makes sense.
So if we started, and so if you think of both of those things with, talking about the concerns of expensive queries first, what is required for a proof of concept just about streaming, just about changing how we read out of the database?
I think we need to just change how do you read the event in the geolog cursor, and how do you process it. But I think that would be great first, that if you can, I don't know how it's hashing the plugins of Ash with the gr on gitlab.com, I talked with him last week, and he said that he's starting to set up the Geo on GitLab station, GitLab.com. So I would like to, or I can try to set up some test machine, but I want to make sure that we can use the Postgres streaming here to write the events from the database. Make sure that you not have any issues with it.
Okay.
Do you think that makes sense? I think that you can start investigating this area first, and
because it sounds also like from the event side, that's where more of the questions come in, and you know, and I do like the idea of having a list of what characteristics the eventing system needs to support, so that we can suggest alternatives if people want alternatives. So it sounds like the database one is the one that is, I don't want to say easier to accomplish, but it sounds like there are less moving parts to accomplish that piece than to start evaluating queuing systems and what that needs to look like. But I have a feeling that the eventing side it feels like it feels like a correct destination to go to, even if all of the pieces aren't aligning yet. It feels like that's the right way to be thinking about the system, to be reading and processing events. But in terms of moving forward from this, I think we need to split this proof of concept in half and do each of the pieces independently of each other. And when thinking about the coding changes that you were proposing, I suppose those coding changes are more around the processing of events, the creation and processing of events, than about the streaming aspect.
yes, this one. Okay.
Yeah.
Yeah, we should do all of this producer and consumer today. This is like,
Yeah.
we're needing these abstractions.
Okay, so there's actually three pieces to this then. The first piece is streaming out of the database. The second piece is changing the code to use producers and consumers. And then the third thing is actually to use eventing instead.
Yep, sounds good.
Okay, so I think the right thing is I'll put a comment on the ticket saying that this was, and link to the recording, that this is basically where we came to at the end of the discussion, was that this is actually spawning three pieces of work. And I'll create the three issues that are related, but I think I'll need some help to fill in all the pieces on those issues. So after this call, I'll raise all of those things and do that.
Cool. I hope that I could make this a little bit more clear to everyone. But
no, definitely. And I think it's useful to have calls about these kinds of things, because there's some things where, like, I don't know how on earth we would have got there in a written form inside of half an hour. So I know that from an async perspective, it's good because people can be part of the conversation, but sometimes it's just useful to have a chat, and it pushes it over that boundary that needs to happen sometimes.
cool.
Cool. Okay. I will comment, add the recording, create issues, and we can take it from there. Awesome. Thank you so much for your times, everyone, today.
Thanks, everyone.
Great. Thank you.
Bye.
Bye.